Fair enough. Thank you, Tom. The most imminent ones, the easiest ones to tackle are high purity. So the industry is used to, in the US today, virtually every source starts at certainly 95, usually 99% pure CO2. So anything you do below that adds cost. So the easiest one to tackle is renewable natural gas. And that's very nice because it's typically 98, 99% pure CO2. There's 1,400 plants already existing in this country, so there's a lot to be tapped into. Unfortunately, most of them are very, very small, 20 tons per day or less of CO2, which just really makes it uneconomic. When you're competing with a 300 ton a day plant, it's hard to get the economics to pencil at a 20 or even a 50 ton per day CO2 plant. Unfortunately, the sources that are the largest renewable natural gas sources are landfill. Some of those are 100, 200, even 300 tons a day. But landfill, as well as wastewater, fall into the category of uncontrolled sources, which means we don't really know what people are putting into a landfill. Anything could go in. We don't know what people flush down their toilet. Anything could happen. So those sources require much more vigilance and testing, and it's hard to really prove negative. So we don't really even know what we should be testing for, although certain companies like Spectrum Carbonics have done some fingerprinting of, I believe, up to 6,000 analytes. And as a result of that, we're making great headway. And I think we're not that far away from having sources being built off RNG sources, perhaps even landfill. And I believe Coca-Cola is in line with that. They realize how important it is to find new sources. And as a result, they have to be open to the challenges of being able to qualify these new sources. So I think we will see RNG first. Shortly behind that is probably fuel cells, which are only 65% or so CO2. But some of those plants will be up to 150 tons per day or even more. And they should be in good geographies. So I think fuel cells will be the next to come down. As you put it so well, the ones that are around the corner, or maybe even a little further down the block, are the lower purity ones. So when you get below 50% purity, the cost goes up quite a bit. You have to have either amine or potassium carbonate cleanup, or maybe PSA or VPSA, or a combination of all the above. So all those plants tend to get much more expensive in a hurry. Some of the easiest ones to tap into could be the old style hydrogen plants, the SMRs, although it's very expensive to do anything inside a refinery. The API standards drive up construction cost. But what I do see is a lot more activity in the industries like lime, cement, and even glass plants, where purity is 10 to 20%. And there are challenges, but again, because of the voluntary interest of these companies in doing something to capture that CO2, it may be feasible. Power plants are another option, but much lower purity. I think there's going to have to be some subsidies involved. Direct air capture will probably be addressed a little bit later on in this discussion, but to get the $180 or $185 credit in this country, you cannot utilize. You have to sequester. So that's how I see the future sources shaping up, gentlemen.